Lesson 6, Rotational Symmetry. Our two standards, G1 and G2. I can verify experimentally properties of transformations, and I can describe the effect of transformations in a coordinate plane. The compass star, as shown at the right, has a rotational symmetry. You can turn it around the center point, when we think about our center point, to a position that it looks identical as the original. Such a turn makes the point of the of the original to an image point on the original figure. The transformation turns the figure, so this is called a rotation as we are looking at this. In this problem, look at ways to describe the relationship between the point X and its image under the rotation is what we're going to be doing. What is the smallest clockwise turn in degrees that we can rotate the star to a new position? And it will look the same as the original. So when we are looking at this one, we want to look at what is our smallest rate of change that we can do. And so if we are looking at this one, our smallest should be 90 degrees, where we would take and look at our picture where we get A to meet up with C. So that turn would be 90 degrees, either this way or this way. So this is our clockwise and counterclockwise. It says, because the original symmetry, the image at each point of the scar is also the point on the rotated. List all the points and their image that matches into part 1. So if we are looking at this, A is going to match to G. We would have G matches to E. We would have E goes to C. And then if we are going around, we have C matches up to A. The next thing we also have is, if we are thinking about our points starting here, H is going to match to F. And some of you might be wondering, why am I going counterclockwise? Counterclockwise is a positive number of degrees. F goes to D. D will go to B. And B will go to H. It says, how can you describe the relationship among any point X and its image at the center of the compass star? So when we are looking at this, and after I write this down, you may need to pause the video so that you can write this down also. But how can we describe the relationship? We're going to say that the segments that connect the form, the segments connecting these points, so them meaning the points, form a 90-degree angle. The path for each vertex forms an arc of the circle. So the path of each vertex forms the arc of a circle. And if we are thinking about that, we're looking at this point G to here, forming the arc of our circle, that arc being that part going around. And we also notice that the vertex is at the center, that we have a center at our vertex. So as you were filling that in, if you need to pause that to write that down, on the top of the next page is where we're really going to start rotating and doing this. It says, thinking of rotating 4 flags at 90 degrees, counterclockwise about the origin. Notice the positive degrees is always going counterclockwise. Counterclockwise is going like the opposite direction of around a clock as we are thinking about that. It says, how do the coordinates in flag 1 compare to their images under a 90-degree rotation? And so try some. So what we're going to do is, I just want you to look at, the first thing we want to look at is flag 1 over here. So flag 1. And then we're going to compare that to flag 2. So flag 1, if we're looking at our points, and again, we want to just list these 4 or these 3 points as we're looking at them. Sometimes we'll even do 4 to look at this one. So if we are looking at those points, we're going to go to 0, 0 on flag 1. We're going to look at the next point going way out, which is going to be over at 3, 0, the top of the flag. kind of this part of the flag, so 3, 0. We're going to have 5, 0, the very top of the flag, and that point going down on the tip of the flag, which is going to be at 4 and -2. So these are all from flag 1. Now we're going to change colors, and we're going to look at flag 2. So flag 2 for us is going to be blue. And if we're looking at those same points going around, we still have 0, 0, so that didn't change. The next one is going to be 3, 0. Not 3, 0, but 0, 3, up 3. 0, 5. And our last one is going to be at 2 and -4. It says, how do flags 2, 3, and 4 compare to their image point? So now again, what we want to do is we want to list, here was flag 1 to flag 2. So now we're going to list again, we're going to put flag 1, or actually we're going to put flag 2, so we'll keep that one in blue. So we'll put flag 2, those 4 points going down. 0, 0, 0, 3, 0, 5, and 2, and it should not be -4. It should be 2, 4. And then we're going to list flag 3, so we can see that. And we're going to look at flag 4 for our last one, so that we can see all of those flags with their coordinate points. And what you may want to do is pause the video so that you can see all these, so that you can get the points written down after you see me writing those. So again, I'm just going to go around flag 3 and flag 4. And what I want you to notice is that as I did flags 3 and flag 4, flag 3, going from our first one to the original one, how did things change? And if we want to think of that, we started with an XY. This is our flag 1. And I think the easiest one to look at is the very last one because it has 2 numbers that change. But notice these 2 flip around, but these also flip. But what happens when you flip them is that in flag 2, we switch the ordered pair around, so what was Y is now X. And the other change we notice is that this 4 stays still positive, but this one becomes the opposite. Now you can't tell in the other ones, so now let's take a look from 2 to 3. In 2 to 3, do they switch around? Yes. And the first one always becomes the opposite. So again, from 3 to 4, how do they change? If we are looking at those, they switch around, and this Y coordinate, the one that's a Y, now becomes the opposite of that. So if we're writing our rule is we start with X comma Y, and how do we change it? It changes to the opposite of Y comma X. Now a lot of times this kind of gets students confused, and remember, this means the opposite of whatever your Y coordinate is here. So the opposite of the Y coordinate in the original, and then the second one is the same as the X one. It's just switch a spot. So it's now my new Y. Okay? And this sometimes gets confusing. If you need to pause it so that everyone can get these written down, make sure you do so. We want to now try this, knowing what we know, and we want to try and rotate it 90 degrees, 180, 270, and 360. And so each time what we're really going to do is we're going to write about those new pairs. And remember, if we go 90 degrees, and this is always for our counterclockwise, we are changing it to the switching them around, and then the Y, the new one becomes the opposite. So before we even plot these, we're going to just think about this rule. So the new rule tells me that the first one, and we're going to do it in green, I should switch the 2 around. So 1, 4 becomes 4, 1. And now the first one becomes the opposite. This is going to become 2, 4. The first one becomes the opposite. 0, 2. We can't take the opposite of 0. That's still going to be 0. And let's plot it and see how this works. So if we are going to -4, 1, that's going to be my new A point. My new B point is at -2, 4. That is B. C is at 0, 2. So if we look at this, does it look like we rotated, and using a straight edge would probably be best. I didn't have one here. Does it look like this is a rotation of 90 degrees? And I think the easiest one to see is, does this point look like it rotates up here and turns 90 counterclockwise? And it does. And the same with A. If we looked at point A going down to the origin to here, this would be a 90-degree rotation. So that rule seems to hold. Let's do one more turn. So this time we're going to switch here, and we're going to use the same rule. So the same rule becomes the opposite. 1 and 4 switch around, and the first one becomes the opposite. This should stay as a -4, remember, because it was -4 here. So we switch them around. 4 and -2 first becomes the opposite. 2 and 0 first becomes the opposite. We'll plot this one in black. Now what you're going to notice as you come back on is that I plotted the black one, and I put those points, and I switched those around also. And so I want you to pause the video if you need to, so that you can get all these points written down. Remember, you are always taking the opposite of the first one, and then as you flip them around, and the second one stays the same. And that's what I did each time. So when we looked at this one, I switched and put the -4 first and -1, and then I took the opposite. And you can see that I kept the minus first, and then I changed it to a plus. I did the same with each of these. So pause the video so you can get it both drawn and so you can get the new points. Because then we really want to look at the rules that are on the next page. So make sure you have those in your notes to talk about. Here, we want to describe the vertices of the triangles as a 90-degree turn. Now, what you notice is that when we looked at our x and y, that the x and y, so we're going to say that the x and the y coordinate, alright, make sure I can write this so you can read it, that the x and y coordinates, that they switch spots, they exchange places. So notice every time we did that, they exchanged places. And then the sign of the new first coordinate, which is our x, the sign of the new x is the opposite. So if it was negative, it became positive. And if it was positive, it became a negative. For some reason, the pen isn't working that great. So if it was negative, and if again you have to go back and look at this, negative became a positive and positive became a negative. What happened if we go from the original one to a 180-degree turn? Well, if you look at this one, look at your original to the 180. Everything is the exact opposite, but the order doesn't change this time. So that's what we want to say. For 180, the sign of the x and y coordinate are reversed, are opposites. I think I like opposites better than are reversed. Are opposites. And we're going to write this down below, but this is kind of where we saw the xy change to negative x, negative y. What happened in 270? So I want you to look at both 270 and the 360. Now 360, that's wonderful. It stays exactly the same. What's happening with our 270? Again, the positions switch. And what do we notice about the second one this time is what we're kind of looking at. So again, the x and y coordinates exchange. So just like in our first one, they exchange places. But then once they exchange places, this time, the sign of the new y coordinate is the opposite. And we're going to write these out algebraically down below, kind of like this rule right here that we did, where we have a little more space. We'll write those in here. 360, x and y are unchanged. They're exactly the same.